All right. Well, welcome to SQL Study Hall, Mark II, second session here. Pretty excited to get started actually doing something concrete. We'll do our best to get through select clauses, where clauses, and you should be able to write a query by the end of this. So just to lay out our goals, today we're going to talk about, just the right mindset, how to think about your programming activities, and also then we're going to get into some actual programming. We'll write basic queries in SQL. Select statements are probably the most common kind of queries. They just pull data out of the database, and that's 9 times out of 10 that's what we need to do. So we'll do that, and then I'll talk a bit about how to filter the results of the query using where. Okay, so let's talk about this programming mindset. I just wanted to get this stated up front because I think a lot of people have barriers to entry in programming just because they are thinking about it maybe differently or analogous to other jobs they've had that don't quite actually line up. So maybe you've had jobs where you just do the same task repeatedly for a period of time, or your job is to just monitor something. Those kinds of jobs obviously super essential, but maybe lack of a certain kind of creativity. And in programming, there is an element of creativity. Obviously, we are not artists, we're not writing operas, but nonetheless, we are creating code from scratch, which means we are creating, right? We are not just doing something by rote. And in order to do that effectively, you got to have a lot of self-love and trust in yourself, and also some ways to keep yourself honest as you're going. So I just kind of listed out a few ways you can think about this. So first, I just said make sure you stay goal-oriented, right? You always want to be thinking, what is this program even supposed to do? What am I trying to achieve with this code? Otherwise, it's easy to just write some cool code or get distracted with some other stuff that might not actually help you. The other thing I wanted to mention is feel free to just start with something crappy. You're going to have a bad first draft, and that's okay. You got to start with something. And if you don't ever get started, you'll never get anywhere, right? And that goes with the next thing. Error messages when you are working with computers as a programmer are going to happen all the time. You'll probably see me spin up an error message at least 10 times today, and only 2 of them were planned, right? Last week, I already put up an error message, or actually, I didn't get an error message when I wanted one, which was just the same kind of thing, right? So you're going to see a lot of error messages as you go. Those are not like a reflection on your personal qualities. They don't make you less of a programmer. They are just steps for you to learn from, and being comfortable dealing with error messages, quickly diagnosing them, things like that. Those are key skills you are going to be learning, and getting an error message is just a chance to learn them, right? On that note, you got an error message. What do you do next? Ask for help. Often the error messages are kind of arcane, and without a little bit of background, you're not going to really understand what it means. So just feel free to copy paste that error message into Google, and Google will tell you the answer, right? There are tons of people who have seen the same error and happy to help you. And if Google doesn't know, or you don't want to talk to Google, you can talk to your colleagues. Probably just shoot me your error message, and I'm happy to talk to you about it. And I'm sure you have friends and coworkers who can help you as well. If you just get stumped on the error message, you won't get anywhere. So yeah, make sure you try to get help and get past it, get a new error message. And on that note, be able to learn from other people's work. If you Google an error message, you're probably going to go to somewhere called Substack where everyone else is asking each other questions. Someone's going to drop a bit of code that solves a problem. There's no shame in copy pasting that code, right? The code is obviously it's creative work. You're going to create something at the end of the day that serves your goal, but you copy paste 5 other people's work to get there. Great job. Everyone draws hands, but everyone draws them differently. Same thing here. You're going to copy their code, but your end result will be your own. And then the last thing, I just wanted to make sure everyone realizes computers are really, really stupid. So they cannot understand anything implicit. They need everything to be explicit, and they need everything to be step by step. So that requires us to be hyper logical when we talk to computers using programming, and almost to the point where you are being illogical. You're saying too many things and being pedantic in a way that you would never be with other human beings. So just always be careful, think through what you're doing step by step. Sometimes I'd like to write it out in a kind of logical ordering before I write any code at all. That can help me. Yeah. Cool. Any questions about this in general? I just wanted to make sure people didn't freak out when they got error messages and stuff. With regard to programming in SQL particularly, there are certain elements of SQL that that require you to be more aware of certain facets of your work. And so these, I've listed out a few key ones here that you just want to always have in the back of your mind when you're working on a project. And since these are probably new and interesting topics to you, let's maybe talk about what these even are. So a table schema is, at least, I mean, you can use it a few different ways, that term, but the way I'm thinking of it, a table schema is the column names and their data types and other facts about them on any given table. You can't really work with a table if you don't know the names of its columns, you don't know the data types of those columns, you're going to struggle, right? You know you want death data, but the table calls it deaths. You can't say, give me death. You have to say, give me deaths, right? So you do need to pay close attention to the schema of the table. And analogously, you have to pay close attention to the schema of the database. The schema of the database is really just all the tables taken together and the ways they connect to one another. We're not going to cover joins here today, but these becomes particularly important when you want to join across tables in your database to compare data across them. Also, you always want to be aware of the data types. It kind of goes hand in hand with the database schema. But if you try to compare a string, which is a text field, to a number field, the system's going to get mad at you and throw an error, right? And sometimes things you think are numbers are actually stored as strings, so that can confuse you too. So you just want to make sure you're always attentive to the data types themselves. And then this gets more into joins and so forth, but I thought I'd mention it up front, and that's cardinality. That means thinking about what each row on your table represents. So sometimes it's kind of hard to tell. If you look at this table, you might not know offhand what does each row represent. But if you take a look at the actual data, you can tell that each row represents the number of confirmed deaths and recovered cases of COVID on a given date, right? So they are by date, by day, right? But some tables might be by person, some tables might be by race, some tables might be by location, and you always want to keep very strong awareness of that so that when you compare them and try to join them together, you don't end up with surprising duplications or accidental filtering, things like that. Okay, cool. I think I'm probably just going to leave it like this. Hopefully you guys can see it because I have to hop back and forth a lot. Let's zoom this one in though, so that didn't help. All right, so now let's dive into actually learning the language, right? Learning a language at a high level requires learning three sort of facets of the language that come together to make the language what it is. And I've separated them here. So first is what is called syntax. That's the structure of the language. So that's in English and German or whatever, that's grammar, essentially, right? Which order do the words go in so that the sentence makes sense? You put the words in a different order, either the sentence makes no sense or it makes a different sense than you wanted it to make. So you always have to pay attention to that kind of ordering, and that's the structure, right? But this is separate from the actual words you put in the sentence, right? So that's where semantics comes in. You have to give the meaning to the terms, and obviously people say, well, that's just semantics. So you're fighting about the meaning of words. Similar idea here. The meaning of the words together with the syntax is what gives the sentence or other unit of language some actual value. Otherwise, they're just random words in the case of semantics, or random rules you need to use them together, right? And last and sometimes overlooked is convention, right? Every language has a convention for how to present it. In written English, right, you put the periods after the words, after the sentences, you put the spaces between the words and so forth. And these kind of give a standard for everyone to use the language in a certain context. Same way with like spoken English, you raise your voice at the end of a question to indicate that it's a question. That's a convention that people use almost without thinking, right? In the context of spoken language, you can more or less break any of these and people don't get too mad. Often there are so many tertiary clues to what you're trying to say that it's almost irrelevant how you actually put the words together. So you get some flexibility there, right? But in the context of programming, because the computer is so narrow in its understanding of the world, it can only understand very specifically things that are in exactly the right syntax and that use exactly the right semantics. So you really do have to pay close attention to the rules there. And the rules are a lot clearer too. They're not like grammar, which is 1,000 exceptions grown up organically. Right? But by contrast, the conventions in programming, you can more or less ignore. They're just for your own use. I actually shouldn't say that. If you're doing a professional job, you should pay attention to the conventions, but they're not as strict for communicating meaning. Okay, that's enough blah, blah, blah about how to get in started. Let's talk about actually writing something. So we're going to start with the select statement. The select statement selects data, as you might have expected. Use the word extract here. You have a table with some data on it. You can extract a subset of that data using a SQL code that is formulated in a select statement. Some common use cases, you create a data set for analysis or reporting. So Tableau, typically, for example, is using a select statement in the back end to pull out certain amounts of data to create the visualizations, right? You can also, applications typically use select statements to figure out what to show the user. So when you click on a page in your disease tracking application, it'll run a select statement against the database to pull all the records for that user and display them to you, right? And if you have problems with your application, you might want to investigate the database, and you could use select statements just to check certain things that are going on down there. Cool, let's write one. So this is the syntax you want to use for a select statement. All select statements have the same basic structure. They start with the word select, and then they have the word from after you provide some column names. What you are selecting are certain columns, and what you're selecting them from are certain tables. Let's look at one in action, right? So if you have SSMS open, it's very easy to pull one up. You can pick any table you like, right-click on it, and choose Select Top 1,000 Rows. You can see I've done that here. And I've got each row listed out, and then you can see the word select there. And then here it says from, and then this is the name of the table there. All right, I'll go into more detail there as well. If you are in BigQuery, you can just go to your table, open it up like you see I have here, and click the button Query in a new tab. This BigQuery is slightly different. It does not specify which columns you select from the start, but you can just put a star here. Star tells the system, do it all, right? So when you run this one, you'll also get, an output of all the tables there. Sorry, all the data there. One thing I'll draw your attention to real quick, again, it's a slight difference between the two. Here you can see it says select top 1,000. This tells the system I only want the first 1,000 rows you find. In BigQuery, it's a little different. You put the limit 1,000 and you put it at the end. They both have the same function, and it's typically a best practice to put something like that in there, just so you don't accidentally pull 10 million rows and get confused why it's taking a while. So let's maybe talk about this in a little more detail. So as you can see, the columns are listed out in order here in SSMS. You separate them with a comma. Right? So the order of the columns determines the order in which they display here in the output. So if I were to take privilege ID, copy that, separate it with a comma, and put it after privilege text, this, when I execute it, oh yeah, I have a comma at the beginning. See, I told you I get an error. Now privilege text is the first of the ones that I see, right? So the order of the columns, you can easily reorder it if their original table is not to your liking. You separate the columns by using a comma, as you just saw. And as you saw in the BigQuery example, a star can be used to designate that you just want all of them, right? So a star is kind of like a free character. So when I used the star, I got every column on the table. But if I didn't want that, I could have just started typing out the list. So observation date, maybe state, region, confirmed, and deaths. Now that I only have these 5, I'm going to lose this SNO, and I'm going to lose this last update when I run this. Right, so I have a smaller table. Good. Sort of a fun other thing that often comes up, you can add a distinct to your select statement to show only unique values. So For example, here I have a lot of regions. I want to know what all the different regions that are in my table, right? So the way I would do that is I might open a new table, new place, go to select, and then I just write distinct region. And then I have to say from, and here I can put in the name of the table. And when I run this one, I have every region listed out one by one so that I could quickly tell, like, is Vietnam on the list, right? Or something like that. Okay, and then last thing I want to just point out on the select, you can easily rename columns as well. So maybe you think region isn't really correct for what you want to do. You can rename it. You just type in, zoom this in a little bit. You can put region as, and then you put whatever you think is cool. Maybe country is better for your needs. All right, so now when I run this, I'll get country, even though the column was named region on the original database. Fun fact, you don't even need the as. That's just for kind of for clarity. If you leave it off, it will just know that you want to alias it without that. Okay, I said a lot of stuff about the select statement so far, and really even just this part. We'll talk about it for an hour. I'll pause there. Any questions, thoughts, things I should repeat?
How does having spaces in those names affect things? Like if you wanted it as country of origin or whatever.
Great call. Okay, so you cannot have spaces in the names of a column on a database. So every table you work with in the database will not have spaces. It will always have underscores and so forth. And as for when you change the name here with the alias, why don't we give it a try, right? You can see it got mad at me, right? The code is expecting a space to indicate a new item, new kind of object. But since I didn't unify these objects, it thinks of is a new modifier for a new term, and then it's like, that's not a real modifier, and it gets mad at me. I think you can bypass that if you tell it to group them together. No, I don't think that. Maybe not. Yeah, I think actually you're just stuck. You can't use spaces. Typically, the workaround is to use an underscore or a dash. So you would do like this. Did I answer your question?
Yep.
Thanks. Let's go. Anyone else? Anything they want to talk about? All right. And I'll press on. Oh, okay. Let's give that a try. I'll try BigQuery too. That might be cool. See, I'm not really, I don't know everything here, so we're just figuring it out. There's so many details about all these. Okay, didn't work here, but let's try it in SSMS. Privilege ID as privilege ID with space. Can execute that. Yeah, good call. So that does seem to work in SSMS. I imagine there's some way to make it work in BigQuery. Maybe two. No, I would have to look that one up. So this is, again, a place where Google's your best friend. But good call, Scott. Thank you. One thing maybe worth noting too, you'll see here that SQL Server Management Studio defaulted to putting the comma before each of the rows, right? It does comma something. And then in here, when I typed it out myself, I separated it with a comma at the end of each. Anyone want to take a guess as to why then I do that? So if you like, you can just think, all right, let's imagine I want to add a new row here. I would just do, okay, what was the other one? The covers. I can just type it in there, but now when I run it, wait, it worked. Should have had an error. Oh, maybe Google is smarter than I thought. But the idea is by putting the comma at the beginning, each row becomes self-contained, whereas if you have the comma at the end, each row kind of has a dependency on the one prior out to it for being correct. So that if you run this, if I delete this comma. Hey, what the heck? It usually throws an error. Do I even need these commas? We're learning a lot today, guys. Yeah, okay. So I guess it got mad here. But if you put a comma there, this is the one. Okay. All right. Well, never mind. That's a bit embarrassing. We'll figure it out later. Let's move on with this document here. I think that's the main idea behind this comma things. Okay. So we talk about select clause. Just to remind you, this is the select clause out of the select statement. And then here we are with the from clause, where we're going next. The from clause needs to uniquely identify a specific table. So that's why you'll see that they often actually are quite long and don't just include the table name itself. Table name is COVID data by country, but we named the entire sort of server object and the database object. That way we are triangulating it, right? So in case there's another table called COVID data by country somewhere else on this server, it's going to know that you want this particular one. And same thing here, when we kind of just spun up a quick query in SSMS, this one also defaulted to what's called a fully qualified table name. The fully qualified table name just means it has the complete address, like spelling out your entire address instead of saying second door on the left, right? So as you can see here, fully qualified name includes every element of the table's location, which typically means you have a server name, a database name, and a table name. Just to sort of give you some context what these mean, the server is typically used to refer to the kind of computational machine that runs the processes as a whole. A server can have many databases, and each database houses some subset of data, and then each database can have many tables. And so that's why between the three of them, you kind of get to the right table. In your from statement, you can also give an alias to the table. At this stage, since you're not joining anything, it doesn't really matter, but you can give it a name here. Let's call this just as COVID. It's not going to show up in the query when we run it because the table name is not part of the output. But in the future, if you ever need to refer to this table, you no longer have to type this huge long name. You can just call it COVID, right? In fact, some people have aliases as short as one letter just to keep things super easy, right? As long as you can keep track of what's what, you can just use one letter. Oh yeah, good call, Ben. Thank you. I should have seen that earlier. That's because the convention confused me. I thought each row was a new column, but because I didn't, it's just aliasing. Okay, and then again, just as with the select statement, you do not need the as. I've typically seen as with select and not with table names. Kind of curious why that would happen. But this here, I'm also successfully aliasing it by just throwing a letter at the end there. Now I can call it C wherever I want. Cool. Same story here. So same syntax, same kind of work. Cool. Just so maybe minor note, you'll see in BigQuery, it's got this backtick in there. That's like the key right underneath escape and above tab on the left-hand side of your keyboard. In BigQuery, that's part of the kind of syntax that it prefers. You can see even without it, the query will run. So it just sort of puts that in there to help you see what's a table name and what's not. It's optional and not required. In SSMS, they frame the column name, each element of the table name with these brackets. That is also optional and not required. If you take those out, you can still successfully query the table. It's just that brackets like that, and it's optional here too, by the way. The brackets just kind of help you separate objects, and they address the spacebar problem like we were dealing with here. And so if you had a table name or a database name that had space in it, you would definitely need the brackets in the sense that you don't when you don't have those. Cool. Any questions on the from part? We haven't really done the fun part of from, which is joins, and we'll do that next time, but more or less pretty straightforward so far. All right, let's talk about where clause, which is the exciting part. So far, all we've done is select some columns. We haven't done any filtering, so we are just pulling every column from the database in no particular order. Not particularly useful on its own unless you just want to see a database. The where clause is what you can use to filter them. You can almost think of it like an if, right? It says, pick every row from the table where this condition is met, or if this condition is met for that row, right? the where clause has a condition right after the word where, and the condition is a comparison between two terms. So you will have a value, some kind of comparison that you want to perform on it, and then the second value in that order. So for example, here on the previous table, we have a region field. So I was comparing the region for each row to this value UK, right? And then I just wanted to note every condition is evaluated per row. So here, if I were to add where, let's do region equals UK, notice that I can surround UK with these little quotation marks to indicate that it's a text value. When I run this, it will filter out everything that's not UK, right? So now I have all the UK rows only. Notice though, by the way, that I called this a region, not the country of origin, even though we call this country of origin in our select statement. If I were to replace this with country of origin, I'm going to get an error message, and the system's going to be like, what are you talking about? There's no such thing called country of origin on that table. That's because the where statement is looking at the table, not at what you want to call things in your table, right? This select statement, in essence, creates a new table of its own results, right? So when you run a select statement, you get this, which is more or less a table object, right? Just kind of not saved on the database. And it's got the new names and new logic that you added to it. When you add a where clause to your select statement, you need to refer to the place you were pulling the data from, not to the new schema that you created by selecting it. Like I said, that confusing way, but does that make sense to people? So yeah, always keep in mind the original table schema for your where clause, right? Let's keep talking about this a little more. So conditions, right? Imajo, what do you mean try alias?
Like C dot country of origin. Can you try that?
Oh, yeah, you can do this.
Works.
You want to try it like this?
Mm-hmm.
Oops. Maybe that'll work.
Okay.
Good try. Always good to experiment. Okay, so let's talk about the condition itself. Like I said, a condition forms a comparison between two values. You cannot compare more than two values, though you can collect values together. So it's a bit tricky. The values, you can specify them however you want, right? Most often, you pick a value from the column itself so that you can have it kind of dynamically work with each column. You can specify a condition where none of the conditions actually come from a column name, from a column. That's very rare that you want to do that. The condition in your where clause does not have to be part of your select clause, none of the values you pull, right? So I could take region out of my query, and then maybe I'll change this to US. Oh, I should have done that. It's just okay. And now, even though I'm filtering on region, you can't tell what region these are from just by looking at the table itself, right? You are just stuck with the other columns. So this can be useful when you don't really want to show anyone the filter. If you're just working for yourself, I typically recommend you do put the region, the filtering fields in the select, so that when you look and you see they're all UK, that tells you something. Otherwise, you can hide from filtering from your own work. Cool. So there's two kinds of values you can put into a condition. One are constants. These are pretty straightforward, right? These are values that will never change. You want to compare every row against the exact same value, right? So that's on this side of my comparison. I have done that, right? UK is a constant. I compare every row on the database to that constant. Notice that if I even just slightly spell this wrong, right? Like if I do United Kingdom, it will return no results, right? This won't be an error. And you might be misled into thinking, well, there's just no data for the United Kingdom on this table. but you should, again, this is where it's important to be aware of what's in your data, look at the region, maybe do that select distinct thing so you can tell what regions are available to you, because you just named the region in a way that the system didn't understand, right? The other thing, fun fact, you can just compare two constants to one another, which is pretty boring and you probably never want to do it, but it's kind of fun. So here I just check, does UK equal UK? And no surprise to anyone, it always equals itself. So you're just going to pull every row when you do this, right? Alternatively, if I said, does UK equal United Kingdom? You can get nothing because UK is never the same set of characters as United Kingdom. Just a little thing there. Couple little things to be aware of. You want to use quotation marks to separate the strings, so to indicate which ones are text values. It doesn't usually matter if you use single marks or double marks. If you have quotation marks inside of your quotation marks, you have to be a little funny with it. So sometimes people put like triple quotes, and then you can put like bird's hat in here. And now, even though there's a quotation mark inside of my string, the system knows that this is correct, right? Obviously, you probably don't want to look for bird's hats in this. Numbers you do not need to do anything with, so we could check where the confirmed is greater than 2, and you just put the number 2 kind of plain Jane in there. You can run this, and you'll get all the dates for which the confirmed was over 2. The other thing probably worth mentioning is null. On a database, null is, and really in programming at large, null is a sort of a special thing. You'll see it in the column, right? So the fields are called null. But if I were to go and say where state equals null, trying to capture this, I will just get nothing. But that's weird because we just saw it on the table and it said null, right? So the way you capture the nulls is you have to use a slightly different syntax. Instead of saying equaling null, equal tells it to compare two values, but null is not a real value. So they have a slightly different way to specify null. You have to say is. So you can say where state is null, right? And now I'll get all those ones that I wanted to see. Add region back, it's weird. And then you can also, for example, say is not null if you prefer to see the ones where they actually have states. It looks like, oddly enough, there's a state called UK inside of UK. I didn't know that. Good. So just be aware of that. It's null, because it is not a real value. It's presented to you in the output just so you're aware of what's going on there. But it's not the same as you know, a white space or an empty string or anything like that. You do have to specify it slightly differently. Cool. Any questions on the conditions and the constants so far?
How does it use null when considering things greater than or less than?
Well, good question. Let's try, but you cannot, I don't think you can, like you're thinking like recovered greater than null?
Or greater than 0, would it pull things that are null? Or less than 10, would it pull the null fields?
Okay, so if you put greater than null, it's just going to get mad, so you can't do that. If you wanted to do greater than or less than 10, and let's see if we get any nulls. I don't think you will, though. So what you might do here is where recovered less than 10 and recovered is null, and now you can check if that's actually going to happen, right? So nothing.
I think you would want or.
Okay. Well, I was just okay. Depends what you want to find. And this here, we can take this part out and see if there's anything with recovered null at all. It might just be a yeah. There's just none of them. Yeah, I'm pretty sure null is just not a number. So even when you do less than, you don't get it because it can't come true. That's worth double checking. Guess we could Google it real quick. Here, I'll make a note in here and I'll add it to the notes when I put this out.
Thank you.
Yeah, what other questions, thoughts? All right. Probably more interesting, variables. This is where you pull a value from each column per row, right? And you use these columns of values for comparison, right? So when I showed you that before, I was using, recovered. That means I check recovered on every row, and I check if it's null, right? And I go down row by row, and if any of the rows is null, then I'll put it in my output. But since none of them were, I got nothing, right? So like it says here, just name the column, choose the operator, and then compare the value. Now the other value can also be another column. So if you wanted to, you could say when recovered equals confirmed. Maybe you want to know, for whatever strange reason, the number of days where there are the same amount of recovered and confirmed cases. And I'm sure there's a few. Oh, look, there's a bunch of them with zeros. So no surprise to anyone. Right? Or you could say maybe there are strange cases where the state is equal to the region, right? We saw that with the UK one previously. Looks like there's some examples of that with the US. Now let's see what happens if you kind of get confused and you try to compare the state with the deaths. Right? You'll get an error of this kind that basically tells you you're comparing the wrong stuff. State is a text and deaths is a number, so these cannot be the same in any meaningful way. So we will refuse to compare them at all. You'll get a similar error here. Let's see, privilege ID is like a disease group ID, is that, so we can see where disease group ID equals, let's do create date. No, this one didn't give you an error, just give you said none of them. Oh, I guess because it's a date field. There's no strings on there. Okay. Yeah, okay. So this is the one. SQL SSMS will try a little harder to convert, but in this case, because the main menu item was varchar, otherwise a string on SQL Server management, the string cannot be converted effectively to an integer value. SQL Server Management Studio is a little clever. If your string only has numerical values, sometimes it will be successful, but you have to have that for every row on that table is stored as a string, but only has numerical values. You have to kind of get lucky, and that's bad database design, but that's can be done.
Can you make the comparison, or can you force the comparison by changing the table state from a number variable to a character variable? In SQL, I know you can do that in some other systems.
Well, okay, so here it'll automatically try to convert varchars to integers, and it'll just tell you if it fails because there's like actual characters in there, right? Like letters. You could, I don't have privileges on this to do it. You could make another column and store it as an integer, and well, you wouldn't successfully load all these values in, right? Because some of them are strings, but you could try to do some logic where you pull the right ones.
So there isn't a way to do that through just where disease group ID as integer equals main item.
You can try like this. There's a kind of method called cast. I forget the exact syntax in SSMS. Something like this. Yeah, it's gonna throw you a similar error when it's not able to do that. Might be worth playing with a bit, but I don't think it'll work when there's actual characters in here. Easier to do would be to cast the integer as a string, right? And I'm not sure the exact syntax for, yeah, they have like varchar. Let's try that. I'll take this off. Yeah, so since varchar is like a super permissive data type, right? You can put numbers or strings. If you wanted to do this kind of cross comparison, for whatever reason, you just cast the integers as strings instead of the strings as integers. Yeah, good question.
Thank you.
Cool. And by the way, what you just saw there with that cast, there are all kinds of little operations like that that are really useful to compare things. Cast is a good one where you need to change the data types. Upper or other string modification ones, right? Like you don't know what case this table is going to have its data in, or you want to catch all of them, just uppercase both of the sides or lowercase both sides, and you know they're going to match, right? You can either do things like coalesce to check multiple columns and pick whichever one has not a null value first. So you could do like, well, here I'll show you how it works in the. By the way, this here where I put 2 dashes, this comments out a line so it doesn't get run when the code runs, but it keeps it there for you to use for the future. That's similar, same syntax here, and it changes the color so you know. This makes it easy to go back and forth. So if we had state region and then we do coalesce state region, it's going to pick whichever has a real value first. So you see state was null and UK was real. So then the confirm. Oh, I had it aliased. Let's give it a real name. There we go, coalesce example. And now it's getting the one that's actually got content. That can be useful when you have multiple columns that have similar values, but some of them are null sometimes. You want to find whichever one's valid. Good. Okay, I'm going to press on. Okay, you can add logic to these, of course. You can and or not. You can nest these as well. So kind of saw me do that earlier a little bit. You can uncomment this. Maybe we want to see where the confirmed is greater than 10, or let's just say greater than 2, and the observation date is greater than, and here you have to give it the date in just the right format. So let's say 2021-01-01, and I gave it as a string. Hopefully that works. Yeah. So now I'm only going to see cases, the days that were slightly bad after 2021, right? And you see already that, and here you can see the coalesce working too, by the way. State had a value, so it chose Wales instead of UK. Good. You can nest these two. So you can say, and observation date after 2021, or region equals UK, right? So by putting the parentheses there, I tell it to check this, then check that. So it's going to get everything that's confirmed and everything that either has region UK or is after 2021. So you'll get 2021 cases for the US, but not for any, but you will get older cases for the UK. You can easily nest those with the parentheses. And good. Okay, just to wrap us up, got a couple things left. The pretty important one here is order by. This also is another kind of clause you can use. Okay, let's maybe not have all this nonsense. And then you can order by to give it a column that you want to order on. So you can order by, in this case, it might be observation date, might be a useful one to make sure that all the dates are in order when you look at the table, right? You might do some experimenting to see which one's order descending and ascending, but the date goes oldest first is by default. So you can change that. You just add DESC to indicate you want it to descend. And now you'll get the most recent data at the top, right? So this data of the set only goes to May of 29, at least for cases where there's more than 2 per day. So it's pretty important because it helps you, like if you wanted to see the most recent data, you're going to need this order by, right? You can order by more than one column. So maybe you might want to see what is the most scary days, right? So we'll order by confirmed. And then when there's a tie for the number of confirmed cases, we'll go by deaths, right? So we can run this. Over here on confirmed, you can see it's ascending, but we want the scariest days. So let's go descending. And now we have really tons and tons of deaths. It's not really the best example because they rarely tie, but you can see that the deaths comes next if you had a tie. Good. You just separate those with a comma. All right. It would be rude of me not to show you some of the conventions that people use in SQL. So you may have noticed already that I'm putting all my actual code words, you might think of it as, in all caps, right? I have select in all caps, coalesce in all caps. Here I slipped and I put as in lowercase. This is not required. Obviously, it ran when as was in lowercase, but putting these in all caps helps you know that these are the code ones, because rarely are normal words in all caps. So it helps you quickly pick them out. Obviously, Google is also doing some clever color coding, but SSMS does less of that. Well, actually, no, it does that the same amount. Yeah. So that looks good. The other thing is you want to put separate clauses on separate lines. So here in SSMS, you saw by default they had select, and then they put all these, and then from was on a separate line. Here we wrote this one from scratch, but we did follow that convention. The code will run just as well if you do it like this, but it's going to be harder to read. And in fact, when we took these away and we accidentally aliased columns, that was a case where that convention was confusing us because we thought the convention would be every row is separate, but without the comma, they aren't. So the system doesn't. Another one is column names and select are all on separate lines. Again, this is optional. You can put them all on one. You can even avoid putting spaces between them, but it just makes things a lot harder to read and harder to tell what's going on. Right? You typically want to use indents to track your subclauses. So this is especially important for logic. So if we were to fix this, if we said where confirmed equals 2, and that's greater than 5 or region equals UK. The probably more formal way to do this is each of these are different clauses. So different parts of the where. So we would do where confirm, change and to another, break it after the parentheses, and then close the parentheses afterwards. And now you can tell, okay, this is one condition, here's another condition, here's its subconditions, right? And you can put them together easily. You could even do this if you really wanted. And then last, like I just showed you, when you open and close a parentheses, you give them their own lines. This is probably familiar to anyone working with like Java or anything, but this really helps you tell that you really did close the parentheses. Google has this nice feature where you click next to one and it kind of shows you where its matching partner is. It's very easy to get lost in your parentheses if you have more than just a couple pairs inside each other. All right, so let's bring it all together. We talked about select, from, where, order by. They do have to be in precisely that order. So always keep that in mind. You have to tell them what you want from where, and then it knows where you're looking for so it can filter them. And now that it's got some stuff, it knows how to order it, right? So if I were to go here and put them in a different order, I'd put order by up here, even though all of the actual wording is good to go, the system is going to be very unhappy with me. It expected the thing to end because it saw order by, but then all of a sudden there was this word where, and it got confused. So just make sure you have them in that order, and you should be good to go. Last thing here, we already talked about the limits and the tops, so that's just a best practice you want to use. I added a link here as well so that you can explore additional SQL functions. There are so many that help you work with strings and figure out exactly the right kind of data you want. We didn't have time to go into every wrinkle, so I just wanted to give you the main idea of how to write a select statement. This will take you to a link to BigQuery's documentation. So there's like, casing, if null, so forth. This is really just scratching the surface even on its own. SSMS has a lot of the same, and I'm sure you can just Google that pretty easily if you wanted to find anything. Well, I just mentioned one really cool example of an easy one, which is you can use this parentheses to indicate free values in a string. So you could, for example, say where, oops, I already have a region equal, or you would use like in this case, and then you put the parentheses, and then I could put UK parentheses, and then I know that if it has like U kingdom, it would work, right? Or if I even take OK out, I'm just going to look for everything that has some stuff, a capital U, and then some stuff. Oh yeah, thank you. I just misspoke there. So this should have UK. But looks like the UK had it really bad because when I organized them by number of confirmed, they got it worse. This data set must not include the US, which would also be caught by this region, or this first 1,000 rows doesn't include them. Yeah. Good. Last, I just wanted to maybe provide a project. I know some people want to have something they can actively sort of take on. I provide this COVID data by country table. If there's a CSV in our shared folder, if you want to upload this anywhere to work on it, obviously it's in BigQuery too. So if you have access to that, you can do it easily. So a couple little things you can work on. First, just get every unique region. Actually saw me do that earlier in the call, so it should be straightforward. Get the region state, observation date, and deaths, order them so that you get the oldest observation dates to the top. Should be pretty straightforward. So let's do that too. And then maybe put it all together. Ask yourself, which country had the most deaths on May 25th, 2021? Kind of classic kind of question you might ask. I have also wanted to mention we have added a few different things to our toolkit and folder. I added this glossary of terms because I just realized there were so many. So I just kind of dropped them in here as we go with a link to the session that we covered them in. If there are some missing here you want to talk about, just throw them on here and I'll take a look and try to put in a definition. Comment me in here as well. And you'll see this in our main SQL Study Hall folder, along with the interest form and so forth. You can view the link to that one. Let's see. Cool. We got a couple minutes. Any last questions, thoughts? All right, well, happy SQLing. Next time we will work on joins, which is its own super fun setup. Yeah. Have a great rest of your day, guys. Thanks.
That was awesome. Thank you.